Hello again, my fellow pilots and aircraft maintenance personnel. Your host is always Haytham Aly, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today, we will have a quiz on the Airbus A320 Ch49 APU Auxiliary Power Unit. We will have 22 MCQ questions to recall and to refresh your knowledge regarding the Airbus A320 Auxiliary Power Unit. Auxiliary Power Unit. You know that the Airbus A320 may have or may accommodate different APU models like APS3200 or APS, and the Honeywell one and the Garrett. Okay, so this question mostly will be for the APIC APU, and also some question will be general for all types of APU or auxiliary power units that may be fit on the Airbus A320 Airbus family. Okay, so let's start the question now, or the quiz now. Okay, so I will join now. Haytham Aly. Okay, so let's start the quiz now. Chapter 49 on APS3200. Okay, so question number 1. What is the main function of the auxiliary power unit? What is the main function of the auxiliary power unit? Okay, to produce independent pneumatic and hydraulic power, to produce independent pneumatic and electrical power, and to produce independent electrical and hydraulic power. So the right answer is to produce independent pneumatic and electric power. Pneumatic and electric power. Okay. As you can see here from this schematic, this schematic show us the three main components that compose the APU, which is a power section, a load compressor, and the accessory gearbox. Okay, so the power section is single shaft, fixed speed, gas turbine engine composed of a compressor, combustion chamber, and a turbine. So the main function of the power section is to produce shaft power to run the load compressor. This load compressor is the compressor to supply the aircraft with bleed source, and the accessory gearbox. So the mechanical shaft power used to rotate a load compressor to supply the aircraft with bleed air, and an accessory gearbox that accommodate mainly the AC generator, which produce 90 kVA. So the APU will produce bleed source and allows aircraft to be independent from ground cart, produce bleed source and electrical power. So if you've been asked anytime, what is the main three components that compose the auxiliary power unit, you can clearly identify. We have a power section, a load compressor, and an accessory gearbox. The function of the power section is to produce mechanical shaft power to run the load compressor and the accessory gearbox. The load compressor is the compressor that will provide the aircraft of bleed, and the accessory gearbox accommodates the AC generator that will provide the aircraft with electrical power. You know that the APU bleed or APU electrical power will be available when the rotating shaft is at 95% RPM. 95% RPM. This auxiliary power unit is a FADEC engine, or the power section, to be specific, is a FADEC engine, which is controlled by ECB, electronic control box. Okay, next question, everybody. Next one, question 2 of 22. Which component control and monitor the APU? The electronic control box, the fuel control unit, or the inlet guide vanes control unit? The right answer is the electronic control box or ECB. The electronic control box or ECB. The APU is a gas turbine engine, and as the main aircraft engine, it is FADEC principal operated. FADEC principal operated. So, what is FADEC? It is a full authority digital engine controlled. So that the APU is a FADEC engine, yes. And the main component of the FADEC is a computer. So what is the name of the APU computer? It is the electronic control box or ECB. Here, the ECB is located in the cargo compartment, after cargo compartment. It is not located on the APU, or it is not located in the APU compartment. Okay, everybody. So, next question. Next one. The electronic control box has restricted authority over APU operation, only APU monitoring function, full authority over APU operation. So the right answer is full authority over APU operation. What authority does the electronic control box has? It has a full authority over APU starting, APU speed governing, APU protections, APU shutdowns. You know that the APU has several types of shutdown. Normal shutdown, emergency shutdown, and automatic shutdown. So, what is the difference between these three types of shutdown? Normal shutdown will happen when you press the master switch of the APU after the APU is running normally without any problem. When you press on the master switch, the APU will be going to off and normally shut down. If the APU was only being used for electrical power, for example, it will shut down immediately. But if the APU is being used to supply the aircraft with bleed air or bleed source, it will take some time to cool down. It is called cool down cycle. For example, it will run for 2 minutes cool down cycle. If you do normal shutdown and the APU was being used to supply the aircraft with bleed source or pneumatic power. What other types of shutdown? Emergency shutdown. Emergency shutdown. Emergency shutdown is an automatic shutdown. Yes. There is what is called automatic extinguishing and shutdown function when the aircraft is on ground and an APU fire is detected, so that the APU will automatically shut down and the fire bottle will automatically extinguished. This is called emergency shutdown. In this emergency shutdown, there will be no cool down cycle even if the APU is being used to supply bleed air. So also from where we can initiate an emergency shutdown? From the APU fire push button. If you ever release the fire push button of the APU will going to emergency shutdown. And also from the external ground card, if you press on the APU shut off push button from the external ground card, any ground personnel like pilots, like aircraft maintenance personnel, like technician, if you need to shut down the APU from ground, you can do from the external ground power behind the nose landing gear. If you initiate a shutdown of the APU from the electrical power, from the external electrical power, the APU will go to emergency shutdown. And it will shut down immediately without cool down cycle. Without cool down cycle. So what other type of what is the third type of shutdown? Automatic shutdown. Automatic shutdown will be initiated, many on ground and less in flight, if any APU parameter will go out of limit. If any APU parameter will go out of limit. So that the ECB has an authority to shut down the APU in many cases on ground and in less cases in flight. This is based on regulation. Automatic shutdown will be less in flight than on ground. Okay, everybody. Next question, everybody. Question 4 of 22. From where can an APU emergency shutdown be performed? From where can an APU emergency shutdown be performed? Refuel, defuel panel, external power control panel, and the cockpit. APU fire panel or external power control panel. The APU cannot be shut down from the outside of the aircraft. So, The right answer is APU fire panel or external power control panel. As I told you just from seconds, APU fire panel, if you release the APU fire push button, you will initiate an emergency shutdown. If you shut down the APU from the external power control panel, here it is a guarded push button. If you press on it, you will initiate an emergency shutdown. And an emergency shutdown is an immediate shutdown. The APU will shut down without any cool down cycle, even if the APU is being used to supply the aircraft for pneumatic power. An emergency shutdown is an automatic shutdown. So why it is called emergency? Because it is mainly for fire situation. If an APU fire happen on ground or in flight, the APU must be shut down immediately without any cool down cycle. So again, the difference between normal shutdown and the emergency and automatic shutdown is that there is no cool down cycle in emergency shutdown or automatic shutdown. There is no cool down cycle in an emergency shutdown or automatic shutdown. And an emergency APU shutdown can be initiated from the APU fire panel. Releasing the APU fire push button will initiate an emergency shutdown, or from the external ground power unit. Also it will initiate an emergency shutdown. Okay, everybody. Let's proceed. Next question. I hope you enjoy this question and you can easily refresh your knowledge regarding the Airbus A320 APU, auxiliary power unit. Okay, everybody. Let's proceed. Next question, question 5 of 22. Normal APU shutdown can be performed from the fire panel in the cockpit, external ground power control panel, or APU control panel in the cockpit. Okay, it is a normal APU shutdown, so it is only being initiated from APU control panel in the cockpit. Okay, so here it is a figure for the APU control panel having two switches, master switch and start push button switch. When the APU is running and you push on the APU master switch, it will initiate normal APU shutdown. The APU will shut down immediately if it is operated and only being supply electrical power. But if the APU is supplying electrical power and the pneumatic bleed air and the pneumatic power, the normal APU shutdown will shut down the APU after finishing the cool down cycle. After finishing the 2 minutes of cool down cycle. Okay, everybody. Let's proceed. Next question. Question 6 of 22. The green APU available indication is displayed when the APU speed is above 98%. This statement is false. Why? Because the green APU available indication is displayed when the APU speed is above 95%, not 98%, 95%. When you initiate an APU start, the APU page, ECAM bleed page will come here, indicating the parameter of the APU like EGT and RPM. Okay, when the APU is running and only when the RPM is above 95%, you will have avail green light on the ECAM and avail green light on the APU panel, So when avail is coming, now you can go to the electric power panel and press on the APU generator and allow the aircraft to be supplied from the APU generator. And also on the air conditioning page, you can press on the APU switch to supply the aircraft with pneumatic power. Okay, so avail green light is coming when the APU speed is greater than 95%. Okay, everybody. Let's proceed. Next question. Question 7 of 22. The bleed pressure indication is not available when either U1 is selected off or has failed, either U2 is selected off or has failed, either U3 is selected off or has failed. The bleed pressure indication is not available on the APU ECAM page when either U2 is selected off or has failed. Okay, everybody. When the APU is running and you can monitor on the APU ECAM page the bleed indication and the electric generation parameter indication. The bleed indication will only come, bleed indication will only come on the APU ECAM page only if either U2 is on, only if either U2 is on. If either U2 is selected off or has failed, you cannot monitor the APU bleed pressure indication on the APU ECAM page. This is why, because it is like a differential pressure and the air data parameter from either U2 must be available in order to calculate the bleed pressure from the APU and displayed on the APU ECAM page. Okay, everybody. Very good. Let's proceed for the next question now. I hope you enjoy these questions. On ground, in case of failure, how can you open or close the air intake flap? On ground, in case of failure, how can you open or close the air intake flap? The air intake flap actuator cannot be overridden. The air intake flap actuator can be hydraulically overridden. The air intake flap actuator can be overridden by a manual override device. The right answer is the air intake flap actuator can be overridden by a manual override device. Okay, everybody. You know that in order to allow the APU to be supplied by air, the air intake flap must be opened. And the air intake flap is opened by an electrical actuator. When you initiate an APU starting and you press on the master switch, it will energize the ECB, electronic control box, and the actuator will be energized and open the air intake flap electrically because it is an electric actuator. So just in case the air intake flap actuator electrical operation is not available or is not opened, ground mechanics can override the operation of an electrical opening of the air intake flap by a mechanical opening, and the actuator has a manual override device that can be used, and with number of turns the ground mechanic can open or close the APU air intake flap. And the aircraft can fly with the air intake flap in the open or closed position. So yes, the air intake flap actuator can be override by a manual override device, mechanically overridden. Yes, it is always electrically operated, but also can be mechanical operated by a manual override device. Okay, everybody, let's proceed. Next question. I hope you enjoy these sets of questions. When is the drain tank emptied? When the aircraft speed is greater than 200 knots, when the aircraft is stopped on the ramp, when the aircraft altitude is above 20,000 feet. The right answer is when the aircraft speed is greater than 200 knots. This figure shows you the drain mast and the drain tank. Fluids from the APU is not accumulated in the APU compartment. By using drain pipes, they are drained into a drain tank, like fuel or oil. And the drain tank must be emptied through the drain mast. So this drain tank will be emptied only if the aircraft in flight and the aircraft speed is more than 200 knots. Differential pressure will act on the fluid on the tank, and through the drain mast, this fluid will be emptied in flight only when the aircraft speed is greater than 200 knots. When the aircraft speed is greater than 200 knots. Okay, everybody. Just a reminder that you can find on my YouTube channel, Aviation Nuggets by Haytham Aly, many sessions like this for different aircraft systems. So don't hesitate to go to the playlist icon on my YouTube channel, and you can find many more sessions like this for all Airbus A320 aircraft systems. Okay, let's proceed this session. Next one, question 10 of 22. Of what kind of design is the compressor? Of what kind of design is the compressor? Two-stage centrifugal compressor design, single-stage centrifugal compressor design, two-stage axial compressor design. The APU compressor for the power section and also the load compressor is a single-stage centrifugal compressor design. This question is specific for the APU APS3200. We have here power section and load compressor. For the power section, we have a single stage centrifugal compressor. And also the load compressor is a single stage centrifugal compressor. Single stage centrifugal compressor. So the compressor is a centrifugal compressor design. Centrifugal compressor design. Okay, everybody, next proceed. Let's proceed. Next question, everybody. Question 11 of 22. What are the main features of the AC generator of the APU? 45 kVA, 115 volt, 50 Hz, 90 kVA, 28 volt, 90 kVA, 115 volt, 400 Hz, 3 phase. The right answer is 90 kVA, 115 volt, 400 Hz, 3 phases. This is the parameter of the AC generator of the APU. The AC generator is located on the accessory gearbox. Accessory gearbox. And it is a generator. The generator of the APU is simply called generator. It's not called IDG. For the main engine, for electric power generation, we are calling that it is called IDG because it is a generator with a constant speed drive. But here on the APU, it is simply a generator. Why? Because the APU is running at fixed speed. Running at fixed speed. So here we are not in need for constant speed drive. Not like the main aircraft engine. The main aircraft engine, as they are operating with different speed, the rotor will operate with a different speed. So the generator will be in need of a CSD or constant speed drive. So it is called IDG. But here on the APU, it is simply called AC generator. And its parameter is 90 kVA, 115 volt, 400 Hz with 3 phases. Okay, everybody, let's proceed. Next question. Question 12 of 22. What are the 3 APU modules? What are the 3 APU modules? Power section, load compressor, and fuel control unit. Power section, load compressor, and accessory drive box. Compressor, combustion chamber, and turbine. As I mentioned before, if we speak about the APU, we have 3 modules. They are power section, load compressor, and an accessory gearbox. So the right answer is power section, load compressor, and accessory drive box. So always remember, the APU is a 3-module design. The main module is the power section, which is a gas turbine engine, fixed speed, single rotor, to produce mechanical shaft power, to run a load compressor for supply the aircraft with bleed, and a gearbox to supply the aircraft with electrical power from the AC generator. Also, the accessory gearbox is composed of other components like fuel control unit, oil components, fuel control units, oil pump and oil components. We have also a permanent magnet alternator to supply the ECB of the APU with electrical power when the APU is running. And we have a fan to ventilate the APU compartment with air. All these components are located on the accessory gearbox. Okay, everybody, on the accessory gearbox. Let's proceed. Next question. Question 13 of 22. Which component controls the ignition and starting operation? Which component controls the ignition and starting operation? The electronic control box, the ignition exciter unit, the start contactor. The main component to control the ignition and starting operation for the APU is the ECB. As I mentioned, the ECB is has a FADIC authority over APU operation. From that, ignition and starting operation. Ignition and starting operation. Here, for starting, we have an electric starter located on the APU accessory gearbox. And for ignition, we have an exciter unit that will control electrical generation to two igniter plugs on the APU combustion chamber. So, the electric starter and the ignition component like exciter unit and the igniter plugs are mainly controlled by the electronic control box. And the electronic control box, or the ECB, is the main component that controls the ignition and the starting operation. The ignition and starting operation. Okay, everybody, let's proceed. Next question. Question 14 of 22. The electronic control box acts on the fuel metering valve and the three-way solenoid valve, fuel metering valve and the pressure regulator. The right answer is fuel metering valve and the three-way solenoid valve. This schematic is show the fuel control unit that supplies the APU with fuel. And the fuel control unit has many functions and has many components. Fuel control unit is located on the APU accessory gearbox. From this component located inside the fuel control unit, the three-way solenoid valve that will be energized by the ECB in order to allow the APU engine start or shut down. And also the fuel control unit has a fuel metering function through a fuel metering valve. So the electronic control box will also connect to the fuel metering valve for fuel metering function. If you ask yourself what function does the fuel control unit has, it has like APU start and shutdown function, combustion function, muscle pressure fuel function, because you know some component on the APU are in need for fuel as a muscle pressure. Here, for example, the inlet guide vane and the bleed valve are muscle pressure fuel operated. They are need fuel as a muscle pressure. Also, other function for the fuel control unit is fuel metering function, fuel filtering function, high pressure functions. In the fuel control unit, there is a high pressure pump and low pressure pump. So also the fuel control unit increase the pressure of the fuel to allow for atomization for the injectors. We have here pilot injectors and the main injectors. Pilot injector are opening in case of APU starting, and in an on-speed operation, also main injector will be supplied. Okay. So the electronic control box acts on the fuel metering valve and the three-way solenoid valve located in the fuel control unit. Okay, everybody, let's proceed. Next question. Question 15 of 22. When APU start is selected, the pilot injector valve open, the main injector valve opens, both the mentioned valves open. Here in this question it asks at starting, so that the pilot injector valves will open. So as I mentioned before, fuel is go from the fuel control unit to fuel manifold. Manifold supplies the pilot injector valve and other supply the main injector valve. Only at starting, the 3 pilot injector will be supplied with fuel. And only after APU starting is initiated and the APU is running on speed operation, the main injector valve will open to supply the main injectors. So at starting only, the pilot injector valve opens. Pilot injector valves open. Okay, everybody, next question. Question 16 of 22. What is the only component of the oil system controlled by the ECB? The de-oiling solenoid valve, the low level sensor, the low oil pressure. The right answer is the de-oiling solenoid valve. The de-oiling solenoid valve. The oil system of the APU is mainly composed of a pressure pump and a scavenge pump, and we have 4 locations in the APU are in need of oil. They are the forward bearing, the aft bearing, the accessory gearbox, and the oil generator. Sorry, and the electric generator. I'm sorry, the AC generator. Okay, everybody. So the ECB will control in the oil system the de-oiling solenoid valve. So what is the de-oiling solenoid valve? It is a valve that will open only during the start in a cold start operation to reduce the amount of oil that will go to the pressure pump, because the oil now is very thick, has a high density due to cold operation. So the de-oiling solenoid valve must be open and allow some oil to go back to the APU tank, APU oil tank, which is the accessory gearbox, to reduce the load on the APU pump during the cold situation. And also during shutdown, the de-oiling solenoid valve will open to allow the oil not go to the compartment after shutdown, and all the oil to be in the oil reservoir, which is the accessory gearbox. So again, the only component in the oil system controlled by the ECB is the de-oiling solenoid valve. De-oiling solenoid valve. Okay, everybody, let's proceed. Next question. I hope you enjoy these sets of questions. Question 17 of 22. How do you check the oil quantity of the APU? How do you check the oil quantity of the APU? On the ECAM oil page, on a side glass, on the oil cooler or CFDS. ECAM APU page, a side glass on the AGB. CFDS interrogation, only by CFDS interrogation on the ECAM engine warning display. The right answer is ECAM. You can check the oil quantity of the APU on the ECAM APU page, because there is a reminder of low oil level may come on the ECAM. And there is a side glass on the accessory gearbox of the APU. You can check the oil quantity from the APU compartment, and also by centralized fault display system interrogation through the MCDU. So we have like 3 ways to monitor the APU oil quantity. And you need to remind that low oil level advisory may come on the APU ECAM page, and the APU still have several hours of operation, even if this advisory is coming on the APU ECAM page. Okay, everybody, let's proceed. Next question. Question 18 of 22. Which component regulates the airflow to the pneumatic system? The bleed load valve, the surge control valve, and the inlet guide vane. The right answer is the inlet guide vane. The inlet guide vane. The inlet guide vane is muscle pressure fuel operated, and electrically controlled by the ECB. And the inlet guide vane will regulate the airflow to the pneumatic system. Yes, we have a bleed load valve or bleed control valve. It will be selected on when you press on the APU bleed on the air conditioning panel. But this bleed load valve will allow bleed to go to the aircraft or stop. And here in the APU APIC or APS, the bleed load valve have 2 functions, bleed load function and surge control function. But the inlet guide vane will control or regulate the airflow to the pneumatic system according to demand. Like you need the bleed from the APU only to start the engine, main engine start, or only for air conditioning, or both of them. So the inlet guide vane will regulate the airflow to the pneumatic system according to electrical signal coming from the ECB. And you need to remember that the inlet guide vane actuator is muscle pressure fuel operated. Muscle pressure fuel operated. Okay, everybody, let's proceed. Next question. Question 19 of 22. Which component have a visual position indicator? Bleed load valve and the inlet guide vane actuator. Inlet guide vane actuator, bleed load valve. Here in the ups, the bleed load valve has a visual position indicator. You can go to the bleed load valve and see if this valve is stuck open or closed, for example, for maintenance and troubleshooting. This bleed load valve has here in the APU ABEC or ups two functions. Bleed load function, selecting on or off the bleed switch from the cockpit, and also integrating the surge control function, to protect the APU load compressor, and during shutdown the excess air will go through the bleed load valve to the surge line to the exhaust pipe of the APU. Okay, everybody, let's proceed. Next question. What does the APU air intake flap open, or when does the APU air intake flap open? As soon as APU operates under air loads, as soon as ignition begins, as soon as master switch push button is set to on. The APU air intake flap will open when you select the master switch. So the right answer is as soon as master switch push button is set to on. As I mentioned before, when you press on the master switch, this energizes the ECB, which is the control box of the APU, and also energize the air intake flap actuator to open the air intake flap. Only when the air intake flap is open, you will have flap open indication come on the APU ECAM page. Okay, everybody, let's proceed. Next question. Question 21 of 22. APU is running and APU bleed system is in use. What happens if APU master switch is released out? The APU shut down after a cooling cycle has been completed. The APU shut down immediately. The APU shut down after the closure of the low pressure fuel shutoff. The right answer is the APU shut down after a cooling cycle has been completed. Why the APU will shut down after a cooling cycle has been completed? Because APU bleed system is in use. APU is running and APU bleed system is in use. Only when an APU bleed system is in use and you initiate a normal shutdown, the APU will shut down after a cooling cycle, a cool down cycle, which is mostly is 2 minutes cool down cycle. If APU is running and only electrical power is being used, the APU will shut down immediately. But because APU is running and APU bleed system is in use, we have cool down cycle. Cool down cycle must be initiated first, then the APU will shut down. Okay, everybody, let's proceed. Next question, and I think this is the last question now. Question 22 of 22. The starter motor assists the APU to which speed? 55% RPM, 40% RPM, or 95% RPM? The right answer is 55% RPM. 55% RPM. Here in the APU ABEC, at 55% RPM, starter disengage and the igniter is ignition system switch off. Because now the APU is running at idle and it is a self-sustained speed now. Okay, everybody, thank you for your good listening. Thank you always for your good listening, and always fly safely and maintain your aircraft very safely. Your host was Haytham Aly. And I thank you very much for joining me to recall the Airbus A320 auxiliary power unit. Again, you can have many like these sessions on my YouTube channel for different aircraft system. So I will be very happy to assist you in your knowledge, and always thank you so much, and I will meet you again. Bye bye.